Okay. I'll also just talk about GDB tools. And GDB tools is, so because I see many have opened the laptop, I start from what usually should be the last slide. So GDB tools is a Python package. It's on PI, so you can install it, and you can actually install it right now if you have a laptop open. Then you can try some simple things during the talk. But first I'll be talking about PrettyPrinter, and GDB tools it's a Python package that contains of two modules, and PrettyPrinter the first one, duel the second one, and I start from the PrettyPrinter. And first let me ask, who knows that GDB has a Python API? Yeah, obviously. And who tried to do anything with Python in GDB? And who knows what PrettyPrinters are? Okay, and who wrote a PrettyPrinter? Tricky question. Yeah.
These two guys don't have.
Okay, so then so at least some of you will recognize the pain, and some others will see an introduction. So that's how most of the examples. I'm MariaDB developer. Before that, I was MySQL developer. So I spent many hours per week inside GDB, inside MySQLD, and most of the examples in this talk are taken straight from my GDB history. So they're all practical, they're all real, nothing hypothetical. So that's basically how usually my debugging session goes when I need to print some of the say easy structures. This one is a bitmap, and I want to print it, so I print it, and then I get to print the structure, and then I need to print the array of integers, and only 52 bits of it are valid. So this is valid, and this end of it is valid, and this is some garbage. So, but I don't want to care about garbage. I just want to see those bits. And there's a string object inside my file, MariaDB. It's a string, it's a pointer, and this is the interesting part because this is the length. And the rest again is garbage, and I don't really want to see the rest of it, I just want to see the string. And that's why GDB introduced PrettyPrinters. Yeah, and there are also complex structures. And that's my probably most hated example. So SQL mode, it's a 64-bit integer where every bit means something. And when I want to print it, so I print it, I get some number. And then I print it in binary, and then I try to figure out what combination of bits creates exactly the same number. And then I eventually arrive at the same number, then I got it. And that actually takes 2 minutes just to print a variable. And this is not MariaDB related, this from glibc. It's in your system includes. It's a caller storage. When you print it, you get a first number, which tells you what those bytes mean. Then you need to interpret them according to this number. And I happen to know that this one means IPv4, so I can print these numbers and I get IPv4. It's not the easiest to print, easiest to debug structure. So this is why GDB has the concept of PrettyPrinters, and when I finally got pissed off of what I've just have shown, I finally decided to write a PrettyPrinter. And this is the GDB has a pretty good documentation, so this is how it usually goes. So you need to create a class that gets a GDB value as an argument, so you need to save it because later you'll need to use it. And then you need to write the actual code that you care about, how to convert the value to the string that you want to see when you're debugging. And then I do it for the second class because I wanted to start from 2 PrettyPrinters. And then I need to create something which called collection PrettyPrinter. Then I need to add those printers repeating the class name 3 more times. So the class name is repeated 4 times just on one slide. And the second format 4 more times for the second class. And then I need to register it. And then I'm done. And by that time I'm already annoyed because this is what I want to write, and this is what I want to write, and not the rest. And that's my problem with this API. And something laptop is slow or what. So, and I need to write a lot of code that I don't really care about. And actually, I just started because I wanted to have 5 or 6 PrettyPrinters, and I also want to recognize pointers. So it will be like 12 different PrettyPrinters. I'm already tired of copy pasting. So this is why I've created this PrettyPrinter decorator, where this is pretty much self-documenting because this is the class name, and this is the code that I care about. And again, this is the class name, this is the code that I care about. Nothing else is hidden beside the PrettyPrinter decorator. And then it's much easier to write and much less code and no copy pasting anymore. And after that, my debugging sessions, they go something like this. So bitmaps are printed as bitmaps, strings are printed as strings. When I print this set of bits, I get immediately bits deciphered in a way. So, and this is how IP storage is printed for me. So, This was very quick, and this was PrettyPrinter. Now the a lot more complex model and more interesting for me. This is the language duel with a strange acronym debugging you might even like. So let me first talk about the history of duel. So my personal first encounter with duel was like 15 years ago when I was debugging some MySQL bug on some old IRIX, and I SSH into it, and I was doing something in GDB, and I did GDB help, and I saw a strange command called duel which I haven't seen in GDB before. So I did help, and it was something cool for printing linked lists and arrays, and I loved it, and I wish Linux had it, and it didn't, so I forgot about it. And then 5 years later, for some reason I remembered it, and I googled and I found that it's not something specific to IRIX. It was actually created in 1993 by Michael Golan, and it was a patch for GDB version 4 at that time. And apparently, from what I gathered from various emails, Michael Golan had some principles and he didn't like GPL, so he put his patch in public domain. And GDB developers, they had their own principles. They required all the patches to be in GPL, and they didn't like public domain, so the patch never got into GDB. So yeah, Michael Golan didn't get his language known, and GDB didn't get this wonderful feature. And I suffered for at least for 10, 15 years without duel in GDB. So everybody wins. But luckily, developers in Gen 2, they weren't that patient about GPL, so I submitted the patch. I ported GPL to GDB 6 and submitted to Gen 2, which is what I'm using on my laptop. And it was in Gen 2 as distribution patch in the whole 2008. Automatically applied if anybody installed GDB on Gen 2. Which later Gen 2 moved to GDB 7 and the patch didn't apply anymore. And I tried it, didn't really apply. It was a lot of changes in GDB 7. So again, I forgot about it. And last year I remembered about it again, and then I re-implemented duel completely from scratch in Python using GDB Python API. So now it's a module that can be loaded runtime. It doesn't depend on anything in GDB internals. It doesn't need patching GDB, it doesn't need compiling. You just can download the Python module. You can load it runtime, you can load it from GDB init. It will work even if you upgrade GDB because it only depends on documented GDB Python API, and I hope they'll keep this stable. So now, what is actually duel, what it can do? So I think this picture is quite familiar to everyone who ever debugged anything. In MariaDB, table list is a structure that contains all tables that are used by any particular SQL query. So if I want to print it, so I first print the first table, then I print the second one, then the third one, and so on until either I print the whole list or I get bored. And with duel, it can be done with just one command. You tell duel to print the linked list, and duel works the list until it gets the null pointer, and it prints every single element in the list. And this is extension of the duel to the. Duel is an extension of C expression syntax in a way. And this is a duel extension of the syntax that tells duel to traverse the linked list using the next global pointer. So every link element must have this next global pointer, and then it will just walk the pointer and print the table name for every element.
Sorry, you might be covering this in the forward slide, but with duel printing out each element of a linked list there,
yeah.
If you've got a PrettyPrinter for that value, is the PrettyPrinter called?
No. So I actually was going to explain the fundamentals later. We're just starting from a few examples. But there's no PrettyPrinter for this. It's just a regular string. And another example from the linked list. This list is a lot longer, so I don't print it. I just want to see how long it is. And then this operator, it tells me how many elements are in the linked list, in a way. And this is an example shows where I want to find whether this item is present in this linked list or not. And yes, sure enough, it's present, and it has number 5 in the list. And one more example to show what it can do with arrays. Arrays are very easy. Because you can use arrange instead of any array index. So you can print the whole list, the whole array with just one command. And it's a very common idiom to have an array where you don't know the number of elements, but you have some property on the last element to mark the end. In this particular case, the last element in the array has the name equals null. So I use an open-ended range saying start from 0 and go, well, ad infinitum, but stop at 0. And then it'll automatically go and it'll stop when the name equals 0. This way I can print arrays where I don't know the length in advance.
What do you do if it's another element than name with 0? If it's another element than name that is 0?
I'll show that later. Oops. Yeah, and this is the one most important thing where the whole logic of duel is based upon. So in C you can write an expression like 1 plus 100, and then 1 is expression and 100 is expression, and the result of 1 plus 100 is another expression with the value of 101. And in duel every expression it can have many values. Instead of 1 you can have a list of 1, 2, 3 for example. Instead of 100 you can have many values. And then when you apply a plus is a regular C operator that only works on individual values. It will work on every possible value pair where first value is taken from the first operand and second value is taken from the other operand. So if you have downloaded duel, you can just type it in and you'll see this very result. And this is generalization works on every C operator, like taking a subscript of an array or of a string. There are two strings and two subscripts, so the square brackets will be applied 4 times to every combination, and there will be for a list. This expression will have 4 values, B, C, and E, F. So it's just a small generalization of the C syntax allowing an expression to return many values. And because of that, it's very easy to go from existing expression that you use in print in GDB to dual expressions in duel. Because this is how I would print a single element from the table option. This is a structure, it has an element called name, so I just won't print the name, I print it like this. There's nothing fancy in here. And I would want to print many, I would simply replace the index with the range, and then I would print many elements at once. Because this is just a small extension of small generalization of existing C syntax. And the same works for linked list. This is intentionally complex example because it's C, so there's the reference in a pointer, then it's casting because it's void pointer, it's C, it's not C++. Then a couple of more references, then I get a long path on my file system, and then I add something just to skip the beginning and get to the interesting part. And if I would want to print the whole list, I would just need to extend it a little bit by specifying how to traverse the list, and then I would get the whole list printed at once. And this works exactly as you might have expected, because in C, or with GDB print command, it would take the value of this pointer, then it would take the data member of this structure, then cast, and then so on. And here, this command with long arrow, those two, it would generate a list of values, and then for every value, it would do this one, and then that one, and then that one. So it will work pretty much like this command, but instead of one value, there will be a list of values. So let's make a checkpoint. So if somebody would want to leave the room right now, that's the one important thing I would want you to remember. So in duel, any expression can return many values, and conventional C operators, they work with many values that basically apply to every value in order. And there are 3 ways in duel to generate those many values. One way is using enumerations by simply specifying many expressions with comma. Second way is using ranges, 2 expressions with 2 dots between. And there can be also open ranges where either first boundary or the second boundary is omitted. And there's also list traversal that I've just shown with linked list. But it's not only for linked list, because by combining those operators, you can just as easy traverse binary trees by saying that you need to start from root and you need to traverse 2 pointers, not just one. This is not a new operator, just combine, because all the operators can be combined just as easily in C as in C. Yes, I don't have example with the circular list. I have example in the manual, and I'll mention circular list later. I couldn't find an example of circular list inside MariaDB, so I don't have this example. So now a little bit more advanced but still useful operators. The operator which I call until, this is this one. This was example I've already shown. It means go from the 0 to every element of the array and stop going when the name equals 0. So this one, number 5, would have had this null pointer in here. That's why duel stopped iterating. But in GDB there's actually this similar thing where you can specify add and then something to print many arrays. And this is some syntax thing that you put at the end. In duel this is not something to put at the end. It's a just normal operator which can be combined with any other operators. Operators just normal. It could be used in the it could be used in the middle of the expression, just the same. Because table field array it's an array of all fields of the table. It's not array of structures like here. It's array of pointers to structures, and it's terminated with a null pointer. So first I need to walk the whole array and stop at the null pointer, and then for every element of the array I print the field name. This is different from this one because here I apply add operator at the end. But this is just to show that it's normal operator. It could be used anywhere in the expression where it makes sense. But in fact, it's related to the question that was just asked. This is a shortcut, a simplified syntax. The full syntax for this operator shows that this here could be the second expression, and the iteration stops when this expression becomes true. So I can walk the whole array and print the whole structures for every element. And I need to stop when the name becomes 0. That's how it stops at the name being 0. So you can put here an arbitrary expression, and the walking down the array will stop when this expression becomes true. This until operator is most commonly used with open-ended ranges. But it can actually be used to do a cyclic list, because then you do again to error operator with a long arrow, and you tell it to stop when the end of the list becomes the beginning. So you can stop cyclic list this way.
What happens if you accidentally press the turn too early before you have the operator? What happens if you accidentally press the turn too early?
Then if GDB will print a screen full, it will ask you continue or not continue, and then you say stop. Or you press Ctrl+C if you disable that. Another useful feature is filters. So in MariaDB and MySQL, there's a concept of virtual fields. It's fields in the table that are generated. And the virtual field is different from a normal field because they have vehicle info pointer being non-zero. So if I want to see all virtual fields in a table, I would probably do something like this. So I would print the whole array, and I would look in what fields vehicle info is not 0. And if I look very carefully at this slide, I could see that it's 2nd, 6th, and 7th. But so there are two problems there. First, I don't really want to look very carefully to look for minor difference in characters. And second, if there would be 100 of fields with only 2 virtual, I would probably miss that. So what I do, I put a question mark in here after the inequality operator, and the comparison operator becomes a filter operator. It works kind of like a grep. So if the result is false, the row is not printed at all, and if it's true, then the result of the expression is printed. So now I can easily see this. The rows, fields 2, 6, and 7, they have non-zero vehicle info pointers. And because this is just an expression, it also doesn't have to be at the end. I can embed it into another expression and print field names just as well by printing field name of the result of this expression. Because this is just an expression that has 3 results, and I can use it by dereferencing the pointer and printing field names. And back to the example with the table names, you have seen this. The duel prints it. First it prints the first element of the linked list, the second one, and then it stops printing a very long path to the last element. It prints this thing in double square brackets. It's not just a way to have a shorter printouts. This is actually a syntax in duel to specify that you want a specific value out of the list of values. So I can just use it and print the third table. And this is a very short example just to highlight how it works. This is a list of 5 values. I want the third value starting from 0, so it's 4. And a practical example would be if I would want to print the last element of the very long linked list. I can just expand the whole linked list, and here I can calculate the length of the linked list, -1, and this way I'll print just the last element without printing the whole thing. So all those operators, can be combined to produce rather complex expressions. And this is again example from the previous slide where I print the last element of the array, and I want to show the operator curly braces. If I wrap this one in curly braces, I won't have the expression in here. I have its value, because curly braces, they work like braces, but they also evaluate the result and print it in here, so I can easily see what element in the array was found by the previous expression. There are also aggregation operators. The one that sums the value, it's not, like I said earlier, I wanted to calculate the length of the linked list, but it doesn't really calculate the length of the linked list. It can be applied to any expression, and it will return the number of values in this expression. So here I do a multiple value expression that works the whole linked list and returns all the elements in the linked list. And then I apply the count operator, and it returns the number of elements in this expression, this number of elements in the linked list. Another one sums all the numbers from all the values in the expression, and it can be used if I want in MariaDB, for example. This structure counts how many times a particular SQL statement was executed, and if I want to do a sum of how many times any SQL statement was executed, I can just do it with duel this way, and then I come to the number 17. And this is not a complete description of duel. There are other operators which are not as often used as those that I've already mentioned. I've mentioned the essential operators that I used pretty much daily, well, some of them weekly, and others that I didn't mention I use maybe never, or maybe once a month. But they came from the original duel that was implemented by Michael Gold, and I tried to preserve the semantics and all the operators. So, yeah.
Well, a number of questions.
Sure.
It's all very useful. I guess the first question is, what license? Sorry, there's going to be a few. What license is the dual PY under now? Is it GPL?
I think it's BSD.
Is BSD?
As far as I remember, yeah.
You know,
yeah, it's BSD 3 clause.
one of the reasons that you mentioned earlier was it doesn't invoke PrettyPrinters on the actual printed values. So, like in that linked list,
Yeah.
for example, I don't know, maybe somebody crazy decided to put vectors in linked lists.
Yeah, so, well, I don't have it in the slide, but it uses normal, because it uses GDB Python API, and it just returns GDB values, so GDB prints them using whatever PrettyPrinters are installed for this particular value. So this one works with PrettyPrinters.
Right. So
The original C patch didn't, but this one works.
oh, that's great.
Yeah.
All right. But I don't need to ask any other questions then.
Okay.
How much is the implementation dependent on the language being C or C++? Would it work with Ada or Pascal or the other languages supported by GEB? And if not, is it complex to enhance?
It will work with any language, but the dual syntax is C-based, so you'll need to use dual syntax in dual expressions. Whatever you use when you do print command in GDB, dual doesn't have anything to do with that. It has a built-in parser that parses expressions according to dual language.
Okay, so it should work.
Well, it will work. You just need to use Python. You just need to use Pascal syntax when you do Pascal expression. When you do print, you need to use syntax for Pascal expressions when you use dual. Yes.
If you had a struct that had a pointer to like an array, and then the struct had a field that was the number of elements,
Yeah.
I didn't see a syntax that applied to that, like where you could use the @sign condition, but
No, you don't need to use @sign condition for that. You can just no. You can just use the range and you can specify length here.
Oh, so you can put an expression.
Yeah, it's everything here is this operator is 2 dots is an operator. Those two are expressions. Everything is an expression, and they can be combined any way you want.
So if you put dot dot and then a name, it will know that the context.
Yeah, it'll check the name of the variable or name of the structure field depending on the if you're inside the structure.
Is that output, the output you've got there, it looks fairly standard. You've got the name of the value and then the value of the value. That's non-customizable, right? You've got to have
No,
left hand and
no. The only thing you have is curly braces. The only thing, if you put curly braces around something, then you have its value in here instead of the original symbolic expression.
Okay.
But I've copied the syntax from the original duel.
All right. So your aim was to do duel as it was.
Almost. Original duel print the string in here. I used GDB standard printer, so I get so the string is printed as a pointer, like in here.
Right.
Actually, what will the operator return the number of elements of an array return in case of a dynamic array, which was allocated with malloc? And you put this hash operator on this pointer.
Well, hash, the counter operator hash slash, it does not count an element in the array or anything. It returns the number of values in the expression. If I would put it in here, it would return 100 because this expression has 100 values. So first you need to, you get an array, then you need to convert it to all values of the array by using square brackets and the range inside. And then this one will return how many values you got.
It actually works with arrays in terms of duel, but not in terms of the underlying language. Yeah?
No.
Yeah.
Sorry, one last question. I promise I won't ask any more questions after that. So you've got two types of expression here, I guess. You've got the expression for duel, which tells you how to print. And I'm assuming then that duel passes the actual expressions, GDB's expression parser, so any casting.
Not. Well, it doesn't pass individual expressions. It will pass THD, and then it will get the structure for that, and then it will get released member of the THD structure.
I'm just wondering how you could, creative casting, how that would work. I mean, say you've got a value and you want to cast it to another value, and whether
it'll get GDB type object for the cast, and then it'll cast the previous GDB value to this one.
Resolve to the structure.
Right.
This is actually what original duel didn't do. It didn't do casting properly because there was syntax ambiguity. And the way I've solved syntax ambiguity, I just assume this is a type, I try to resolve it to a type, it doesn't resolve it to type, as a result is a dual expression.
Okay, that's great.
Yes.
Has anyone tried to use this in LLDB?
Yeah, I've got this question, so in a sense, I've got it as a issue in GitHub. I didn't invest any effort into that. I mean, with LLDB, I'm not particular. I don't know. Maybe if there are many more requests, I'll look into it. I guess it should be pretty short to separate the parser from the GDB API stuff. And then it might be possible.
I think this question should be better asked that they could adopt this. As far as I understood, it's kind of independent, and you can easily adopt it. So you can just write LLDB dev and ask them.
Any more questions? Any more questions?
What about expressions with function calls? What about expressions with function calls?
Yes, so that's some limitation of GDB Python API. So I can do function calls. It can invoke normal functions. It cannot invoke GDB built-in functions, and it cannot invoke object methods, because object methods and GDB built-in functions, they are not callable when converted to GDB value. So there's a bug report about that, and there's not much activity around there.
Do you have have you filed any other GDB bugs about missing features?
No, I guess that was the main one.
There's a question there.
Yeah, go ahead. You have a question? You have a question? Could you please speak up louder?
Can you use dual expressions with the display command?
Display integer. Could you change the vocabulary like change the base,
Change the display of this one? No, because it's designed. It was designed to easily print and analyze structures. It's not a language to generate pretty reports out of your data. So there's not much formatting of what you do with the data. I guess I can. Like this.
Thank you.
How extensible is the? Do you have any plans to make it more extensive? For example, you can define your own special operator, like the app operator, which does something for this the dual language.
No, so far the only thing I did that was not in the original duel was this plus operator, but it's a parser written in arpeggio of this Python model. It could be extended to understand. If you want to extend it and do something that you think is generally useful, not only for you, then do please submit a pull request and I will. Yeah, of course.
Trying to be pretty good.
That was a very good talk.
Thank you for the talk. It was very nice.